Genetic Modification by Kylie Hearn.
Oliver Lance.
Kaylee Cruz.
So genetic modification, also known as genetic engineering, is a process where scientists deliberately alter the DNA of an organism by adding or removing or changing specific genes. Using genetic modification, we can cure cystic fibrosis, alpha-1, I don't know how to say that, hemophilia, and sickle cell disease, which are normally uncurable. To make a vaccine, researchers can insert particular DNA sequences into the plasma in the right location to force bacteria or yeast into making the corresponding protein to make a new vaccine. And genetic modification can sometimes have genetic modification can also have some unintended side effects or off-target edits, leading to an unexpected result that could be negative. And then there are potential risks associated with genetic modification, including unintended environmental impacts and potential allergic reactions in the consumer. And then genetic editing tool could modify a different gene, potentially causing unexpected and potentially harmful consequences due to disruption of normal gene function.
Ethical concern. It is important to know the difference between the benefits and the negatives of genetic modification. Genetic modification has a bunch of different diseases that it is able to treat, like Oliver mentioned, sickle cell disease, muscle dystrophy, and cancer. And the treatment from those sicknesses, from those diseases, can cost a lot of money. So genetic modification can assist with the cost of the hospital bills. And then it assists the aging population because genetic modification can also help Alzheimer's disease, which 6.7 million Americans over the age of 65 have, and it assists infertile couples. And the precision of the tool, it allows scientists to uncover roles like the biological processes, and then it can also benefit plants and animals with the plants it can help get rid of pests, and then for both of them it can help treat diseases. And the consequences of genetic modification is many genetic diseases that it can cause, which can be passed on through generations. And then the health division between currently developing nations and already developed nations. And it could result in hereditary changes like designer babies, and the unintended aftermath issues like precision. So the tool can be reliable, but the doctor also isn't that reliable. And then genetic modification can cost anywhere from $1 million to $3 million. And the expenses could also create a lack of accessibility. And genetic modification can lead to unforeseen effects.
Okay, so financial implications. The overall impact, so according to the National Institute of Health, 300 million people worldwide are living with a rare disease, and 70% of those are genetic disorders. The Eversana healthcare database claims that the average cost per person per year for someone with a genetic disorder is $8,000 to $140,000 per year. And the same database said that the average PPY was $5,000 for healthy individuals. So the cost of genetic modification, the Institute for Clinical and Economic Review estimates that it is an average $2.2 million for genetic therapies. So the Zynteglo example, hemophilia is a genetic disorder that is caused by your blood not being able to clot properly. The National Bleeding Disorders Foundation says that treatment for hemophilia costs an average $300,000 every year. According to the National Institute of Health, the average life expectancy for someone with hemophilia is 77 years. So assuming that someone lives to 77, the total cost for their clotting therapies will be about $23.1 million. Zynteglo is a one-time treatment that costs between $2.1 and $2.4 million. And genetic therapies have the potential to save someone with hemophilia up to $23 million in their lifetime. So the social economic impacts, exclusivity. So genetic modification oftentimes are denied by insurance companies because they are not viewed as medically necessary. This can mean that wealthy people are the only group with the ability to receive genetic therapies because they're able to pay for the modifications out of pocket. And desirable traits, being able to guarantee that your offspring will have desirable traits can also mean that you're guaranteeing them success in the workplace, which can put them above other people in their life. Amelia?
Earlier trials, such as the National One Matrix trial, use genetic screening to match different treatments to different groups of patients based on the genetic changes in their cancer, opening hundreds of new opportunities and advancements in the future for more clinical trials. As technology continues to advance, it has personalized medications. As technology continues to advance, it has the potential to yield more efficient treatments and preventative care tailored to each person's unique genetics. Collaborative trials, such as the National One Matrix trial, employ genetic screening to align patients with suitable therapies that correspond to their genetic profiles. Working on more personalized medications gives us many new openings to widen the scope of what can be treated with personalized medication in the future. The risk of designer babies. Wealthier individuals may gain access to better health and opportunities, while disadvantaged groups could face increased challenges with the advancements of genetic modification. While genetically modifying embryos can eliminate hereditary diseases and offer benefits like eradicating sickle cell anemia, they also raise significant ethical and social concerns for our future if the upper class has perfect designer babies, yet the lower class is left with the majority of the imperfections that genetically modifying embryos to rid of hereditary diseases for the upper class, leaving the lower class with more disadvantages.
Okay, so our solution, we need to find a way to balance maximizing the benefits and minimizing the harm. Genetic modifications have been used for many medical breakthroughs, such as curing otherwise incurable diseases, curing types of cancers, synthesizing personalized medication and immunizations, and as well as saving people with genetic disorders hundreds of thousands of dollars. So denying that there are beneficial effects is foolish in our opinion, and we believe that we should not completely outlaw genetic modifications. However, we also think that there needs to be very strict laws on how we use it and who can use it, so that there will not be just reserved for the wealthy, and that they are used for scientific benefits only. So we are proposing the idea that people who are looking to use genetic modification should have to submit their case to the International Review Board so they can review the ethics of the case and make sure that there is no foul play happening, because although this technology has caused many medical breakthroughs, it also proposes many numerous ethical quandaries. So we just want to make sure that people are using them for the right things and that we do not create that kind of class gap.
Thank you. Any questions?